Hello students, so today we will be mainly discussing about defects in crystalline materials. Now we can categorize the defects into either a point defect or a line defect or a surface defect or a volume defect. Vacancies and substitution. Or substitution and to some extent interstitials. They come under point defect. That means if we have atoms periodically arranged in this fashion, and suddenly there is absence of say one atom here, like in this case this position is vacant, so this comes under vacancy. Or it may so happen that the atoms one of the atoms may be replaced by atoms of different kind, so that becomes a substitution. And apart from this, it may also so happen that the interstitial positions of the atoms, they are filled with atoms of different kind, so that comes under interstitial defect. So all these three kinds of defect, they come under the point defect. Now this is the case of crystals. However, there are crystals or which are ionic solids. Mostly ceramics, where there are two types of ions. One is cation and one is anion. Say these are, for example, the cations. These are cations, positive ions, and there are also negative ions. Like this. So in this situation, so this is negative. This is an anion. So in this situation, we can have Schottky and Frankel defect. So the Schottky defect is the one which consists of an anion and a cation vacancy. Now, the condition of formation of this defect is that the charge neutrality should be maintained. So, in a Schottky defect, a loss of an anion is compensated by a loss of a cation, so that there is no charge deviations. And in the case of a Frankel defect, there is a vacancy of, say, one of the ions, and similarly that vacancy is compensated by an interstitial. So these are the point defects. Next most common type of defect is, as already discussed, is dislocation. Which is absence of half plane of atoms. Suppose you have atomic energy in this fashion. And in this case, suppose one half is absent. So this again is represented by a Burgess vector. And you can have two types of dislocation. One is screw dislocation and one is the edge dislocation. Absence of half plane of atoms. So apart from that, grain boundary is also considered to be a dislocation. Means you have atoms arranged in some orientation in one grain, and adjacent to it is another grain where the atomic orientation is different. So this is the grain boundary. So this is also considered to be a defect. Now usually, as the material is under plastic deformation, there is certain slip lines and slip system which makes a dislocation move. Now at the grain boundary, the dislocation's direction needs to be changed. So that's how having more number of grain boundaries, if the number is enhanced, then automatically the strength of the material also gets enhanced. And the way of enhancing the grain boundary region is to decrease in the size. This is normal Hall pitch effect. Now the dislocation which are represented by this Burgess vector, if they are so arranged that you have a system is formed where one side or a boundary is created in such a way that the atoms, arrangement of atoms in one side of the boundary is exactly the mirror image of the atoms on the other side. So in that case, this boundary is called a twin boundary. And this also comes in the surface defect. The grain boundary and twin boundaries.